Okay, we are interested in the question, when are states distinguishable? When are they different, or when two states in an automata are in fact the same state? If they are not really the same state, they're at least equivalent. Okay, so given a DFA, we define two states as equivalent if for any string W, if we start from P and we go with W, right, we feed it into the DFA, we end up in a state. And if we go from Q and we feed it string W, those two states that they end up with P state and the Q state, those two states are either both accepting or both not accepting, right? What it really says is that P and Q are indistinguishable as far as functionally as they behave. If you start working from them, and all you know is whether when they arrive with a string, the state they arrive to are accepting or not accepting, those two states look completely equivalent. So we define them as equivalent. And the intuition is that if we have two states in automata that are equivalent, we can just merge them into a single state. And we can repeatedly apply this merging operation and end up with a smaller automata. Okay. Equivalent, we say that two states P and Q are distinguishable if there is a string W such that if we go from P with W, we get into a state that is an accepting state, but if we go for Q and W, we end up with a state that is not accepting, or the symmetric situation, right, which is essentially the same. Okay. So now we can speak, instead of speaking about states, we want to speak about strings, because we are dealing with languages and we care about strings. So two strings, two prefixes are distinguishable, right? We can distinguish them if there is a suffix such that one of the suffixes is in the language while the other one is not. Okay, so let's do it a bit more carefully. Given a string W, I'm going to define nebula of W as the state that you end up if we start with the start state with the string W. So nebula of W is the state that you can associate with the string W. So every string, there is a state associated with it, which is the state you arrive if you start with the start state with this string. Okay, and now we say the two strings are distinguishable if nabla of U and nabla of W are distinguishable. What it really means, if you unroll the definitions, is that two prefixes are U and W are distinguishable if there is a suffix X such that UX is in the language and WX is not in the language, or the symmetric situation. Right? So now we essentially have a way of saying whether two prefixes are in some sense, whether they can be distinguished by adding different suffix to them. Okay, and now here's a simple lemma that turns out to be very important. It says if two strings are distinguishable, then they lead to different states. Okay, where nabla of X again is the state that you get if you start at the start state with the string X. And let's do a proof by a figure, right? If they are distinguishable, right, X and Y are distinguishable, then if I apply, I start from the start state and I go with X, I end up with one state with X and one state with Y. And then from those two states, I go on with W, right? And then I continue to, with one of them, I get to accept states, the other one I go and I end up with a non-accepting states, right? So this is the natural situation, right? This is in our notation going to be nabla of X. This is state you end up with the string X. That is the nabla Y, right? What is not possible, that is in fact those two strings are the same those two states are the same state, because if they're in the same state, then in one case you take this state and you continue with W and you end up in accepting state, and from the same state you continue with W and you end up with a non-accepting state. And that's of course impossible because those two paths are the same path. It's a DFA, it's not an NFA. Given a string, we can do only, the path is uniquely defined. Okay, here is the formal definition using, stringology. All it says is essentially that, it's essentially the same proof as in the figure. You just essentially argued that it must be that the string, the state of YW, the state that you arrive to, if you start with the string YW, this state is both an accepting state and a non-accepting state, and that of course is impossible. And the argument is essentially the same one in the figure. Let me not go over the low-level definitions, the low-level details. They're in the slide if you're interested. Okay, so now we have this notion of distinguishable states and also distinguishable strings, right? So a few review questions. Prove that for the language 0 to the k, 1 to the k for all k, which we already know is not regular, for this language, for any 0 to the I, 0 to the j, where I is different than j, those two strings are distinguishable. Okay. The second question is to show that if we have k strings that are all pairwise distinguishable, then any DFA for this language L must have k states. And the final question is to prove again that 0 to the k, 1 to the k is not regular using the above two parts. Okay, and that's it for now.